Astronomy, Part 3. Galaxy Quest! Galaxy formation. How on earth did our galaxy, or on the universe, or whatever, did our galaxy form?
So this comes basically from a big cloud of gas and dust that kind of was eventually, gained enough clumps of matter and stuff that it became heavy enough to collapse, and it would collapse under gravity.
What does that mean? Collapse under gravity. Cool concept.
Collapse under gravity is just, it means that, if you take this cloud of matter, the cloud will kind of fall in upon itself because gravity has this, gravity is this very powerful force when you have a lot of mass, and it kind of makes everything fall in together. So we start with something that's much bigger than the size of the solar system, actually, a cloud of gas and dust, and then we have these things kind of contract and they fall in enough until they get to be dense enough to start forming stars. And this happens when you can have nuclear fusion in the middle of this, big gas cloud thing. And when this happens and the sun starts shining and things turn on, then we get things being pushed out, and these things that are pushed out, they'll also clump together and stuff like that, and that's how we get the planets and the asteroid belt.
So should we be thinking of these as kind of, sort of like little magnets that are all kind of coming together? I mean, should we think about heavy gravity, mass as little magnets that are just kind of attracting each other, like this is a Saturday night party on J-Date or something? Or
yeah, you can kind of think of it like that. It's like everything, all of these little particles, rather than being held together by a magnetic force, are held together by gravity. But it would be an analogous thing if you were to throw a whole bunch of magnetic marbles and stuff onto a floor and throw them in random directions. Yeah.
What created the different densities of the planets?
So it has to do a lot with the compositions, the different chemical elements that are in there and stuff like that. So the Earth being mainly like silicon oxide, stuff like that.
Silicon oxide sand, you mean?
Yeah, sand. So we have some kind of characteristic density. It's the gravitational pull of a planet is actually directly related to the mass of the planet, but we get these gas giants and stuff out in the outer solar system that are made up of these mainly gaseous things, and so they collect together, and we end up with this kind of, more of a cloud type of planet than the rocky planets that we see in the inner solar system.
Makes sense. And presumably, when the cloud kind of planets get closer to the sun or whatever their gravitational center is, they burn off the gas and they become more dense?
Yeah, it could kind of boil it off, yeah, basically.
Got it, okay. Yeah, boy, got a lot of friends who could use that. How did our galaxy form? Why do densities vary between planets and stars? What is a gas giant, other than a politician?